Hey guys, and welcome to your lesson for the day. Today's lesson is over finding least common multiple. Now, I do need you to get your own piece of paper and write these notes down. Okay, follow along with me as I go through each thing. Now, if you understand it, that's great. But again, what you need to do is write this down. So, least common multiple. When you break it down by word, least obviously means the lowest. Common means it's something that two things both share. And then multiple, that one might be a little bit more difficult to explain. So you need to know what a multiple is. So what are multiples? Well, multiples are a factor that is being multiplied. Okay, so it's really similar to skip counting or counting by the number that you're presented with. So if you were given the number 2, for example, the multiples of 2 would be 2, 4, 6, 8, 10, 12, and so on. You keep going. You can keep counting by 2s for literally forever. So some more examples for you here are multiples of 6, which would be 6, 12, 18, 24, 36, 42. They keep going. They're not just what I have listed here. Multiples go on forever. It literally means that you are multiplying the number you're given, so such as 6, over and over and over again. It's going to keep increasing. You're skip counting. So examples of multiples of 4 would be 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. You can literally go on forever, okay, guys? So when you're listing those multiples out, it can take a while. So if you're listing, be careful and make sure you don't skip one of those skip counting numbers. It's really easy to do. So one of the things you need to notice is that there is a difference between factors and multiples. Factors are going to be small numbers for the most part. When you're dealing with multiples, you're literally multiplying. It's in the word itself, multiple multiply. Okay? You're going to be increasing that number as you go. With factors, they're going to be small. They're going to be smaller numbers than what you started with, or they're going to be the number itself. So today what you need to know how to do is actually find the LCM, and we are going to use the prime factorization method. So remember how we were finding GCF using the Venn diagram? We're going to follow that same state of mind, and we're going to follow the same exact process, but now we're going to be finding LCM using that instead of the GCF. So I want to take my base numbers, or my numbers that I'm given, and I actually want to break those down into their prime factorization. Okay, so with 12, I need to break that down, and the first thing I think of is 2 times 6. So that's what I'm going to write as my prime factorization here. 2 times 6, okay? And I do have a prime factor here, and that is 2, so I need to acknowledge that. 2 is a prime factor. So I need to keep going and keep breaking down this 6 because I know it's composite. It can be broken down further because 6 is not a prime number. So I'm going to keep going, and 6 can be broken down into both 2 and 3. And notice that those are already highlighted because I knew that they were both prime factors. We've already dealt with 2. Okay, so that's another prime factor. So I'm going to list this in expanded form. So that would be 2 times 2 times 3. And then I'm going to come over here and I'm actually going to break down my 20 now. So 20, I know, can be broken down into 2 and 10. That was the first thing I thought of. Remember, you can do 4 and 5 if you wanted. If that was the first thing you thought of, we're still going to end up with the same expanded form. But I know that 2 is prime, so I'm going to go ahead and highlight that. And I'm going to keep breaking down my composite number of 10. Okay, so 10 can be split into the factors of 2 times 5. And again, those are both prime numbers. So I'm going to write my prime factorization now in expanded form. So in expanded form, that would be 2 times 5. Okay, so just like we did with GCF, we want to find what the two numbers have in common. So looking at their expanded forms, I can see that they both have a set of 2s. So they both have 2 2s. Okay, so I'm going to mark out the 2's. Remember, I'm not listing every 2 that they have in common. I'm not listing all 4 2's. I'm looking at their expanded forms and saying to myself, okay, they both have 1 2, they both have 2 2's. So that's why only 2 2's go in the middle. So now I'm going to put in my other numbers that were not in common. I'm going to put those with their appropriate numbers. So 12 still had a 3, and 20 still had a 5. So now, in the past, what we've done is multiply the 2 numbers in the middle together to find the GCF. Well, that's part of it, but again, we're not just looking at the middle anymore. We're looking at everything. So to find the least common multiple, I need to use this entire Venn diagram, okay, the whole thing. So I want to take every single number inside the Venn diagram. Be careful you don't go back to your expanded forms. Those are not going to be helpful right now. We only need to use our Venn diagram. So I'm going to look here and I'm going to say, okay, well, I've got a 3 times a 2 times another 2 times this 5 that's still over here. So we're using every number in the Venn diagram. So to solve this, I need to do 3 times 2, which is 6, 6 times 2, which is 12, and then 12 times 5, which is going to give me my least common multiple of 60. Okay, so the smallest number that you can expand these numbers into or skip count with to get to the same one is 60. So we're going to try another one. Okay, so we've got 6 and we've got 10. So again, like I've done in the past, I'm going to come over here and I'm going to take my base numbers. I've got 6 and I've got 10, and I'm going to break those down into their prime factorizations. Now, lucky for me, these are pretty small numbers, so that means they won't have a very large expanded form. So I know that 6 can be broken down into the prime factors of 2 times 3. You can do 3 times 2 as well. Remember, they're the same. Doesn't matter what order as long as you've got the right numbers. All right, so to list out an expanded form, that's going to be pretty easy. So that's going to be 2 times 3, just like what we have, because nothing is repeated. It was really simple. Okay, 10, again, another one of those smaller numbers, so I shouldn't have a very large prime factorization. That can be broken down into both 2, hang on just a second. Here we go, 2 and 5. Thankfully, those are the only other factors of 10 other than 10 times 1. So I'm going to write that in expanded form. And again, it's going to be pretty simple since that was the only thing I could break it down into. I've got a 2 times a 5. So again, I'm going to look at this expanded form and say, what do these two numbers have in common? Well, they have 1, 2 each. Okay, so now I'm going to put that 2 in the middle because that's what they have in common. And I'm going to place my other numbers that they did not have in common out here on the sides of the Venn diagram. So remember, the 6 still had a 3 and the 10 still had a 5 that was not in common. So using my Venn diagram, I am going to find the least common multiple by multiplying everything together. 3 times 2 times 5. Okay, so 3 times 2 would give me 6. 6 times 5 would give me 30. So my least common multiple is 30. Now, if you were thinking it was 60, you have to be careful. You can't just take two numbers that you're given and multiply them together and assume that that is the least common multiple. Because if I did that, that would give me 60, which is a multiple of both 6 and 10. But again, we're looking for the least or the lowest common multiple that they both have. That's what common means. Okay, so be careful. Do not make that mistake. Sometimes it works, sometimes it doesn't. So don't fall into the trap of just multiplying the two numbers together. All right, we've got one more that we're going to do together, 9 and 15. So again, I've got these nice small numbers, which means to me that my expanded form's not going to be super huge. So I've got 9 and I've got 15. So let's break it down. I've got the 9, which is going to be split into 3 times 3. And I know that 3 is prime, so I'm highlighting it. And since they're both prime, I'm done. And so now I can come over here to 15. And 15's multiples would be 3 times 5. And again, I've got those nice prime factorizations here. And as you can tell, when I write these in expanded form, they're going to be pretty short. So the expanded form of 9 would be 3 times 3. Expanded form for 15 would be 3 times 5. Oh, look at that. Somehow my 5 got unhighlighted, so let's re-highlight that because it is definitely a prime number. Okay, so again, looking at what I have in common, I see that they both have 1, 3 apiece. So I'm going to put that in the middle. Need to unhighlight that though, that's distracting. And then 9 still has a 3 that the 15 didn't have, and 15 still has a 5. Alright, so coming up here to find my LCM, that's going to be 3 times 3 times 5. Remember, I'm using everything inside the Venn diagram, not down here. I don't want to do that, okay? So looking at your Venn diagram, so 3 times 3 would be 9. 9 times 5 would give me 45. So the LCM of 9 and 15 is going to be 45. Okay, so I use prime factorization to find LCM because it is a much faster way if you're looking for both GCF and LCM, because you can kind of knock out 2 birds with 1 stone. Remember, the stuff in the middle is your greatest common factor, and then you use the entire Venn diagram to find least common multiple. But there are alternate ways if you're not comfortable using prime factorization. There are 2 other methods. You've got multiple mountain, which you may have heard of if you went to Matt Elementary last year. And then there's also the T-chart, using the multiples of the number. So if you'd like to use either one of these, you're welcome to. But here are the strategies so you know how to use them. So if I'm doing multiple mountain, what I have to do is actually list out or skip count using the number 4. So the first multiple of a number is always the number itself. Okay, then 4, then 8, 12, 16, oops, that's not a 16, 16, 20, 24, 28, 32, 36, 40. And the thing that I don't like about this, you guys, is that it's really easy to make a mistake. It's really easy to skip one of those numbers. So just be careful. Just be aware of how you're counting and make sure you don't skip a number. Okay? And remember, the multiples of 4 will keep going, but I decided to stop after 10 because that's a lot of multiples, y'all. Okay, so for 9, always start with the number that you've got. I'm going to change the color. So I've got 9, 18, 27, 36, 45, 54, 63, 72, 81, and 90. So I went all the way up to the 10th multiple of 9. Okay. So you don't really have to keep going if you notice that they have something in common, but you do need to be extra careful that you don't skip a multiple, like I said before. So looking at these 2 lists, I usually start with my greater number because, as you can tell, it goes up quicker in value than the 4, so it's going to take me less time to find that thing that they both have in common. So I see that they don't have a 9. The closest thing is 8, and that is not 9. 18, no. It's got 16 and 20, but no 18. 27, nope. 36, oh hey, look there. I do have a 36 in common. Okay, they both have a 36. So that is my least common multiple, 36. Okay, the T-chart is essentially the same thing, but instead of using the letter M, it's just you lining up the multiples together in the form of a chart. Okay, so again, I'm going to list those multiples. 6 is always going to be the first one for 6. You always use the same number first. That's always, every number's first multiple is itself. So 6, 12, 18, 24, 32, oops, skipped one, 30, 36, 42, 48, so on and so forth. I'm going to stop there because I kind of got tired of listing, to be honest with you. 8 for 8 is the first one. Then 16, 24, 32, 40, 48, 54. Oh, you guys, this is exhausting. Okay, so if I'm looking at my lists here, again, I like to start with my top or my highest number because you're more likely to find it quicker. So 8, don't have an 8 in the sixes. 16, nope, closest thing is 18, and that's not going to work. 24, okay, yes, I do have 24 in common. But notice that I also listed something else that they both had in common, and that was 48. But be careful. Remember, we're looking for least common, lowest number. Okay, so while 48 is a multiple of 6 and 8, it is not the lowest or the least common. So again, don't fall into that trap of just multiplying the two numbers together. So my least common multiple for 6 and 8 is 24. Okay, on the next page you're going to get practice. So here are some practice problems. You may use whichever method you find most helpful, whether that be the Venn diagrams that we used back here, okay, or whether that be using multiple mountain or a T-chart. That is up to you. Remember, you can look back at this video at any time to review what we've done or get a refresher on how to do the steps. So pause the video now, and I want you to actually find the least common multiple of these three numbers. So pause it now. Okay, so you should have solved these three problems. If you didn't, then you need to again pause this video and actually solve them, because I'm going to show you the answers now. So for 3 and 7, your least common multiple is 21. Notice you could actually just multiply those two numbers together and find it, but that only works because both of these numbers are prime, you guys. 3 and 7 are both prime. That's why it works, okay? So for 2, your answer should have been 60. That is its least common multiple. And for 3, 36. Okay, so those are your least common multiples for these three. If you have any questions, then you need to email your teacher and tell them the question that you have, and I'm sure they will answer it as soon as they can. After this, you will be completing a short, what's called a test, but again, it's because it's self-grading. It's going to tell you guys your score after you've done all 3 attempts. Okay, so after you have done that, please make sure you've tried your best, scored as high as you can, and then if you still have questions and you're still not sure why you got a question wrong, please email your teacher again. Thanks so much, guys, and I hope you have a safe and happy day.